So to balance equations when it's quite difficult, you will need to draw out a table. So you need to put all the elements on the left hand side and right hand side, and this is how you count them up. So if there was oxygen here, there's so let's look at carbon dioxide. There's one carbon here. Oxygen, there's two there plus one there, so that makes three, and hydrogen, there's two. So you just count them up in that way. Then you go to the most complicated compound first to make sure that one's balanced out, because it is very easy to correct the simpler ones, but if you change the complicated ones, you end up changing it in several other places at the same time. And so we're going to deal with this compound first. So there's 6 carbon here, there's only 1 there, so we need to get 6 on that side. That influences this compound here, so now there's 12 oxygens plus 1, so there's 13. And so moving on to that, we are then going to even up the hydrogens, the H2Os, and where are we? The oxygens here. So in order to get these hydrogens same on both sides, we put a 7 there, that makes 14. And that brings that out to 19. So everything is good except for that. So I've purposely chosen this particular reaction as a harder one because you don't normally have to go to this step. And so just to make a quick jump to correct these two, you just throw a fraction there. So you put 19 there, and then that will 19 divided by 2. And because there's an O2 there, so you have to times that, the total there is 19. So if you just put 19 there, 19 times 2 is 38. So divided by 2 is actually 19. So that's how you do this sort of clever fraction. And then all you have to do is times it all out, so you have whole numbers, because there's no such thing as half molecules. So times everything by 2, that becomes 12, that becomes 14. That's your final answer. Okay,